Hi everyone, welcome back to this series. In the last part of this series, we created our basic Node Express server. Now, I want to start implementing the GraphQL API on that server, because right now our server is not really doing a lot. So let's dive right into that, and let's make sure that by the end of the video, we have our first GraphQL API implementation up and running. So I'm back in my project here with my running development server, started with npm start. And I will quit it now because I now want to install extra packages to make my GraphQL API run. Because, as you learned in the first video of this series, GraphQL is basically a specification that defines a query language which clients can send in the body of a post request to the backend. So the job of the backend will be to parse these incoming queries, to understand these commands sent by the frontend, and deliver the right data back to the frontend, or do whatever the query instructs us to do. There also are mutations which want the server to save or delete or update something. So parsing these queries will be important. And to parse a query, we essentially need two parts, you could say. First of all, we need a package or a tool that is capable of understanding GraphQL queries. Now, these queries are standardized. The keywords you can use there are standardized because there is a specification. So such parsing packages exist. The other part is that we need to define the capabilities of our API. We need to define which kind of queries can we handle, which kind of mutations can we take care of. Because if a front-end application wants to get all users, this is only possible if we defined a so-called schema on the backend in our GraphQL API that knows what to do when such users are requested. So we'll have to take care about both. Now, for the parsing and for registering our schema and so on, and for matching our schema to the resolvers, which is the code that actually takes care about what needs to be done, for all of that, we can use packages. For writing the schemas and defining the schema of our API, we are the only one who can do that. So let's first of all install the packages we need. I'll do that with npm install --save, and I need two packages here. The first one is express-graphql. This is a GraphQL package that can be used as a middleware in Express Node.js applications, and that allows us to point at a schema, at resolvers, and automatically connect all of that for us and route requests to a parser and then handle them according to our schema and forward them to the right resolvers. So a lot of magic work that will be done behind the scenes by that package. The other package I will install is called just GraphQL. The GraphQL package, in the end, will allow us to define the schema and set up a schema that follows the official GraphQL specification and definitions. And that will give us a valid schema. It will not just check it. It will also basically convert it to JavaScript code, to JavaScript objects, you could say. So it will parse our schema and convert it, and we can then use this parsed and converted schema together with express-graphql, you could say. So these are the two packages we need, and I will just hit enter, and how we use them will become clearer in a second. With both installed, I'll run npm start again to bring up that development server again. And now let's start setting up our GraphQL environment and schema here. For that, I'll go to the app.js file, and here I want to import something from that express-graphql package. I'll name it GraphQL HTTP. The name is up to you though. And I will simply import that by requiring the express-graphql package. This package essentially exports one thing, and that thing, that GraphQL HTTP here, happens to be a function that we can use in the place where Express expects a middleware function. So it basically exports a valid middleware function. And what this middleware function will do is it will take incoming requests and funnel them through the GraphQL query parser and automatically forward them to the right resolvers. And that will be our duty to set the resolvers and schemas up. So how do we use this middleware? Well, instead of having this GET request here, I will now add a normal app use statement. And here, I want to handle requests that reach our GraphQL endpoint. Now, remember, the first video in this series there I mentioned that with GraphQL, you have only one endpoint to which all requests are sent. Typically, this is reached under the GraphQL path of your domain. So yourdomain.com/GraphQL. You can name this however you want, though. You could also use /API or whatever you want. I'll go with GraphQL. The second argument here is our middleware function then. That is normal express.js code. And the middleware function here is our GraphQL HTTP function we imported from the express-GraphqL package. Now, in there, we pass a JavaScript object where we configure our GraphQL API. Because this express-GraphqL package basically needs some information pieces from us. Where do I find your schema, which defines the endpoints, so to say, the real endpoints you can handle, so which defines the queries you can handle. Where do I find the resolvers to which my requests should be forwarded once I identified the query this request wants to execute? These are the questions we need to answer here, and we do this by passing two keys here in this object, two properties. The first one is the schema property, and this should point at a valid GraphQL schema. Now we will be able to generate this GraphQL schema with help of that other package we installed, the GraphQL package. So for now, let's just point it at null. The other key we have here is our root value key. And that will in the end point at an object, a JavaScript object, which has all the resolver functions in it. And resolver functions need to match our schema endpoints by name. And this will become clearer once we add our first schema and our first resolver. So now that we added these two keys, we are almost ready to make our GraphQL API work. Of course, it's not doing much though. So let's add a schema. And for adding a schema, I will import something from that GraphQL package. So I will require it from there. Now that something is an object, and I could name it GraphQL like this, but I will use a modern JavaScript syntax, which is called object destructuring, which looks like this. You have curly braces on the left side of the equal sign. And now I can pull out properties out of that object, which this package happens to export. And I can store the values of these properties in equally named variables that are then available in this app.js file. And here I need the build schema property, which happens to be a function that takes a JavaScript template literal string, which we can then use to define our schema. So this build schema function takes a string, and that string should define our schema. The advantage of this approach is that we can build our schema as a string, so in a convenient written form, and the heavy lifting of converting this to JavaScript objects and so on is taken care of by this GraphQL package. So this GraphQL package will generate a GraphQL schema object in the end based on our written schema. We used it down here where we need to pass such a GraphQL schema. There I call build schema, and here I will pass a template literal so that we can write a multi-line string in here. This is a normal JavaScript string. I'm just using backticks here because backticks allow me to write a multi-line string here in JavaScript. Now, to define that schema, we need to add a schema key here. So this schema keyword needs to be present. Then we add curly braces. And now here, we have to define two special keys. One is named query and one is named mutation. Now, incoming GraphQL requests know queries, which means we want to fetch data, and mutations, which means we want to change data. Well, there also are subscriptions, but we'll ignore them for now. So we have queries for fetching data and mutations for changing data. Changing data includes creating it, updating it, or deleting it. So we need to have these two root commands, so to say, in this schema object. And this also has to be named schema. This is all required because, always remember, GraphQL has a specification which defines all these things. So by adhering to this standard, packages like GraphQL can do their job and can actually parse our string here into a valid GraphQL schema object because they are looking for certain keywords. This build schema method here, or this function, is looking for specific keywords. So we have these two root keywords in this schema object. You can basically say we have two properties in this schema object here. Now, how does a query look like? What is a query here? And what is a mutation? Well, obviously, we have more than one query we want to support. Maybe we want to be able to fetch a list of events and a list of users and data for a single event. And we want to be able to mutate different things, create an event, create a user, update an event. So we can't just map this property to exactly one action. Instead, what we use here is we use another feature of the GraphQL specification, and that is types. The GraphQL language is a typed language. It works with types to define what a certain endpoint returns and so on. And for that, or therefore, we can create a new type with the type keyword. Again, a keyword you have to use. And there, you can name this now however you want. I'll name it root query, but this could be named differently. And this now also is an object. And in this object, we'll define the different real endpoints we support for incoming queries. And I'll do the same for a mutation. Here, I have my root mutation. This could also be named differently. And there, I will define my different mutations. In this query, so in the schema object down there, I will now point at root query, which will basically bundle all my supported queries. And for the mutation, I will point at root mutation, which bundles all my supported mutations. And now we can add as many queries and as many mutations here as we want. Now, if you're coming from a REST API world, this looks super strange at the beginning. And I'm totally aware of this. Writing this code here, writing this string essentially, that is not very intuitive if you previously defined routes and had your middleware functions or your controllers doing something when a request hit that route. But you always have to remember that GraphQL simply works differently. GraphQL still gives you an API, but this API is not controlled by different routes or endpoints, but it exposes a full query language to the frontend. And therefore, we need to define our own interpretation for this query language behind the scenes on the backend. Or we basically need to, define what commands we want to support, what data you can fetch. And that is also the reason why GraphQL uses types, because this makes it easy for us to talk about one and the same thing. We are very clear about which data a certain endpoint returns and which data a certain field holds. But step by step, we are not returning anything at this point. We have our root query and root mutation object, but both do not hold any data. Now let's say here in the root query, we want to be able to return a list of events. So we might support a command which is called events. You could also think that you use get events, and you could absolutely name it like this, but it's pretty common in GraphQL to basically treat this, regarding its naming, as if it were a property of an object. And in an object, you would have an events property that holds a list of all events, right? And therefore, we name this events here too, because we basically think of it as being accessed like a property on an object that magically holds a list of all the data this should return. In this case, a list of events. So here we have a list of events, and this query also returns some data, of course. We signal the return type by adding a colon, and then on the right side of the colon, we have the data that is returned. Here, let's keep it simple, and let's say this is a list of strings, an array of strings. In GraphQL world, or in the GraphQL specification, you define a list of something. So you basically say, hey, this will return a list of something by adding square brackets on the right side of the colon. And then inside of these square brackets, you add the type of data that is inside of the list. So here, if we have a list of strings being returned, then I add string here. GraphQL supports a couple of types: strings, integers, floats, booleans, and you can learn all about that in the official GraphQL docs, of course. There are more types than the ones I just mentioned. We will also see a lot of types throughout this series, though. String is one of the built-in types. Make sure it has a capital S. And I want to make clear that this will always return a list of strings. And I can do this by adding an exclamation mark after string. So it can't be a list of null values, basically. This means it's not nullable. It will always return a list of strings. And it will always return a list and not just null. It might be an empty list, that would be valid, but not a list of multiple null objects, and also not null as a response. So this is our query. Now let's also add a mutation. Here we would probably create an event. And just as when we work with normal JavaScript objects, creating or updating and so on, so basically not getting data, there we would typically call a function or a method on an object. And hence we will name this mutation just as we would name a function. We would not name it event, we would name it create event typically. Create event is what we create, and there, let's say we expect one value, the name. We can name this however we want. And then the type of this, signaled by adding a colon after it, also will be a string. And this then might return, let's say, a string again. So maybe it just echoes back the name of the event we wanted to create. Now we have defined these two commands or these two properties of our root query and of the root mutation our GraphQL API should support. Now, this is the first step. This can now be parsed, and this is now what we expose to the front end. However, when we send requests, nothing will happen right now, because whilst we do have our schema in place, we got no logic to act on incoming requests that request a list of data or that want to add an event with the create event mutation. And we add this logic in the root value, in the resolver here. So this is simply called resolver in the GraphQL world, and this root value is a bundle of all the resolvers we have. Now, here is one important thing. The resolvers for your commands, like events and create event, need to have the exact same names. So if you have an events query here, then you need to have an events resolver here. So an events key in that resolver object. And it's the same for this mutation. Important, of course, you should name your queries and mutations such that they don't clash. GraphQL has no namespaces and so on, so each name here really is unique. Events here matches events here. Now with that, how does a resolver look like? Well, a resolver is really just a function. So events here is a function in this resolver object, and I'm just assigning an anonymous arrow function here. This is how a resolver looks like. This function will be called for you by the express-graphql package in the end when an incoming request looks for this event's property. So when an incoming request requests this event's property. So here we just want to return our list of events then. And of course, here without a database and so on, we can just return what we promised to return, a list of strings. So I will return an array here with a list of events, like romantic, cooking, sailing, and all-night coding. This is now my events resolver, which will trigger for queries, querying for events. Now let's also add a resolver for create event. For that, I'll add a second property in this root value, so in our merged resolver. And this has to be named create event because it's named create event up there. This also is a function, and this function now also receives an argument, to be precise, an args object. This is an object holding all the arguments this might have gotten. I didn't talk much about it, but this actually, obviously, is a query, a property, that accepts a list of arguments. Now, you could also accept arguments on queries that return data only and that don't mutate anything. Here we could also, for example, filter events that are booked, so that could be a Boolean. This is also something we'll add later. So argument lists can be added to any query, not just mutations. For mutations, it often is the case, though, because often we need data to make a mutation. We need to know which data to store. We need to know which ID or which event with which ID to delete. So here we have an argument list on this create event query or on this create event operation. And therefore here we get this args object. We would get it here too, by the way. Here it will just be an empty object because we have no arguments. Here we will have arguments. So we can now access our event name with the name here on this args object. So event name can be retrieved from args.name. .name because I named it name up here. If you named it differently, you have to name it differently down there. And then here, I will just return back that event name. As we have no database, I can't really store it somewhere. So for now, this is my simple GraphQL API. Now, to see it in action, we got a couple of options. Option number one is that we simply send a post request to /GraphQL, and we try to write a valid GraphQL statement in that post request. And that valid GraphQL statement would be a post request with a request body, where you have a string as a request body with your GraphQL data in it. Now, we will take care of this later because it's a little more complex and you can pass extra data. For now, we will use a built-in debugging and development tool, which express-graphql ships with. And we can unlock this tool by adding a third property after schema and root value, which we pass to that object we pass to GraphQL HTTP. And that is the graphical property. And by setting this to true, we get a special URL we can visit, where we get this nice user interface you saw in the first video of this series, where we can simply play around with our API and test it. So I will now save this with all these changes made. And now let's go back to the browser. And on our page, let's visit /GraphQL. And you will get this nice graphical user interface here, where you can play around with your API. And the nice thing is that you even get auto-completion here. How is auto-completion achieved? Well, it fetches metadata about your API behind the scenes. And since GraphQL is a typed language, it knows perfectly well which type of data, for example, the create event query expects. So here, how do we write a query now? Well, first of all, you have to define which kind of query you want to create. A normal query, which fetches data, or a mutation, which mutates something. These are the two keywords we have here. We also have subscription and fragment. We'll not take care about these two. These are the two main types of operations we have. Now, query is what I want to do here. I want to get data, let's say. So after this, we could give this a name, get events, but this is optional for now. So I will just add curly braces. And again, since this is optional, you can also omit the name. And then here you define your own action you defined. Now, we have only one query. We only have events because that create event thing is a mutation, right? We map it to mutation down there. In our root query, which is mapped to the query object, or to the query property, we only have that events action. So therefore, if we press Control white space or Control blank here, we only see events in the auto-completion. We can hit events here and then add another pair of curly braces. And now we can't define more because we have no nested object. That will be something we can do later. Then we can pick the properties of the events we want to get. Here we can just request events like this, hit enter, and indeed we get back this object with the data key, which holds an object with the key of our action, of our query, events. And then this has the return value. And if this return value would be a nested object, then we could even dive into this with another pair of curly braces here and pick the fields we want to have. And that is something we'll do later. For now, let's stick with this simple example, which proves that the API works. Now let's also see a mutation in action. So mutation, we could give this a name too, but I will make it an anonymous mutation here. Hit Control space here again for auto-completion. We only have the create event mutation, so this is filled in automatically. And this now takes arguments. So we should add a pair of parentheses here. And we have one argument here, which is of type string. It's the name argument because I named it name here. And now if I hit enter, after a colon, we define the value. Since it's a string, it should go between quotation marks. And important, these have to be double quotation marks. You'll get an error otherwise. And I'll name this sports and hit enter. And indeed, you see, this worked. We get no error here. We get sports as a result here because in our resolver for create event, we basically return the data we passed in. So this is the first basic GraphQL API. It's not doing much, but I hope that I could at least help a little bit understand how it works behind the scenes and what the core idea is. Now obviously, we'll enhance this and make this more useful over the next videos in this series, but this already is a nice start that hopefully is interesting to you too. So I hope to see you back in the next videos of the series. Have a great day. Bye.